Hey everybody, Michael Snyder, Pacific Northwest and California Weather Watch. I thought we'd go ahead and do the discussion on the April 2025 ENSO update. This acronym is El Nino Southern Oscillation. This is the discussion of what phase we are in for the Pacific Ocean across the equatorial Pacific, La Nina, neutral, or El Nino conditions. So let's go ahead and take a look at where we are and where we are headed as we go on in towards the summer, the fall, and the winter months. So why does ENSO matter so much? Well, because equatorial Pacific is very important. There's a lot of moisture and a lot of heat contained across the equatorial regions of our planet. So we want to know how that heat transfer takes place. And based on the sea surface temperatures here, we can get a pretty good idea of the patterns that may take shape, and sometimes months in advance. And if we take a look here, this is another way to view it. Dew point temperature, again, equatorial Pacific here. There's the Hawaiian Islands in Japan. Polar regions or mid-latitude regions there are much drier, relatively speaking. And if we look at the northern hemisphere view, you can really see just how dry we are across the top of the planet there looking down. And versus the equatorial regions, of course. And same thing here, again, looking at the precipitable water map also. So warm air holds much more moisture and energy versus the dry air. So this heat transfer has big implications on the ridges and the troughs. It can mean drought for some areas, rainier than normal conditions, snowier, colder, warmer, you name it. And we get a fairly decent idea, at least it's our best tool anyway, to see what is coming in the months ahead. So what happens in the tropics does not stay in the tropics. There's this delicate balance in this heat transfer going on across the planet at all times. Now, the Southern Oscillation Index is one way we can look at this. And we're going to go over this in more detail here in a little bit. But there's Darwin and Tahiti. We've been keeping records for these locations. Lower pressure over Darwin here. It means La Nina conditions. Generally speaking, where you get that lower pressure, you get the deeper convection. And then, of course, you get the big heat transfer occurring here versus higher pressure over Tahiti. El Nino is basically the reverse, and we're going to go over that here a bit more towards the end of the video. But El Nino or La Nina, it's a phenomenon in the equatorial Pacific Ocean characterized by a 5 consecutive 3-month running mean sea surface temperature anomaly in the 3.4 region. So we just got out of a very weak La Nina, or maybe even just a chilly neutral. I don't know how it's going to be classified exactly, but it wasn't a very strong La Nina. And this is where we measure that between 170 west and 120 west there across the equatorial Pacific. You can see the Hawaiian Islands right there, plus and minus 5 degrees north and south of the equator. So looking at the monthly sea surface temperature here, you can see we did go into La Nina conditions, but did we stay there long enough to be officially classified? We'll see how that goes. Right now, it doesn't really look like it, so we might end up being classified as a neutral year there. And if we look, this is January 13th all the way through April 6th. You can see the dates to the bottom left there. And you can see some of the warming here occurring off the coast of South America. But even as we go on from January into April 6th, we're still a little bit chillier than normal across some of this region. And I'll show you that in the Southern Oscillation Index as well, because it still kind of thinks we are in that La Nina flavor. Now, looking at what was going on April 23rd, you can see at depth out across some places east of the dateline we're warmer than normal and still got some of this cooler than normal, just barely a hair below low, maybe right around 0 Celsius there across the equatorial Pacific. And some of that warmer water is very shallow there across this off the coast of South America. And you can kind of see how we've been going here for, this is March 4th, and this is April 18th down there, and this is April 23rd. So it's looking a bit neutralish right now, but the atmosphere kind of still has that La Nina flavor. I'll show you more on that here in a bit. But right now we are dead neutral here at 3.4, the region. And you kind of see how we've been bouncing around in those La Nina temperatures here for a bit. Then we spiked back up as we went on through the month of March and April. So this is all the way back to May 2024. You can kind of see that cooler than a normal water. And as you go May, June, July, you can see month by month. And you can see this is the sea surface temperature anomalies. And this is the La Nina, El Nino region would be right about here. So you can kind of see how this warmer water has been building in. But then right here in the month of April, we've been cooling it back down a little bit again here. Now, something interesting here is that we compare the sea surface temperatures across the equatorial Pacific, but we have to update them. I think we do it about every 5 years. Yes, we do. And you can see, going all the way back to 1951, we do a 30-year running timeline, 1951 to 1980. We've been increasing each 5-year chunk, and now we're at 1991 to 2020. And you can see we've warmed almost a half a degree there, maybe a little bit less. across the equatorial Pacific. Now, taking a look at where we are going as we go through the summer months. So right now we're in neutral conditions here, but as we go on in through the summertime, you can see the La Nina odds again increase here and pretty close there. As by the time we get towards December, that's kind of a coin toss between if we're going to be in El Nino or neutral conditions. But also we cannot completely rule out an El Nino, in fact, because even something like the European model is showing actual possible weak El Nino coming up. So we are not too sure, but that's kind of what neutral looks like here, I suspect, at this time. So right now, still the odds-on favorite as we go on in towards next fall and winter is neutral conditions. And you can see the model average here. A little bit better chance, it looks like, overall of being in a weak La Nina, but probably the best odds, again, in neutral conditions. CFS is kind of saying the same thing. You can see a little bit on the chilly side there across the equatorial Pacific as we go on in towards the fall months here, but generally in neutral territory. And the European, though, a little bit of an outlier. You can see El Nino would be right there. So some of the ensembles do have things being in an El Nino year. So we're kind of all over the place right now, but that's kind of what I suspect the neutral years will look like. Now, we get that deep tropical convection, and it's not only ENSO or El Nino Southern Oscillation. There's other factors at play, like the Madden-Julian Oscillation. So these cycles are usually about 30 to 60 days, and these circle the globe in that 30 to 60 day time frame there. Increased rain can move out over the Pacific Ocean, then it circles all the way back around across some of the Atlantic, and across Africa, and then emerges back out across the Indian Ocean. There's different phases, and we can kind of try to predict the weather based on that as well. So these can work in tandem, and you can see in phase both wet, extreme wet event, in phase both dry, very dry event basically. And yeah, you can kind of see it. And if both of them are out of phase, maybe you'll be kind of neutral or kind of around average there. But yeah, these will phase in and out as we go through the fall and the winter months here. So that's why in an El Nino year, you're not always going to be in that El Nino pattern, or vice versa. When you're in a La Nina year, you're not always going to be in that pattern, because you have these different phases of the Madden-Julian Oscillation moving across the planet here that can kind of send Kelvin waves, and it can mimic different phases of ENSO overall speaking. So hopefully that makes some sense. And let me try to explain it a little more here, because you can see the average MJO cloud and wind pattern. So when you're looking at the green here, in the darker green, that would be the deeper convection moving across the planet. Then you can kind of see the subsidence and the sinking air in the wake of that, or out in front of it, however you want to look at that. And you can kind of see the circle of the planet. And you can also see how the jet stream responds. Now notice when it comes back across the Indian Ocean, moves over the maritime continent, you see that jet stream get stronger off the coast of Asia there, or pushing out over Japan. And that in turn, of course, you get that stronger jet stream, you can get ridging downstream, and then you can get troughing downstream from that, and it affects these Rossby waves and jet streams all the way across the planet based on the phase of the Madden-Julian Oscillation, and especially when it lines up in tandem with whether you're in La Nina conditions or El Nino conditions, then of course you can exacerbate those conditions as well. Ridges and troughs and jet streams, and you can kind of see that here. You can see how they all affect each other. You get a ridge out here, a little bit, towards Asia there, and you get a trough, and then downstream of that, you're getting a ridge, and then another trough, and then another ridge downstream. So if you know where the heat transfer is going to be persistently over a season, you can kind of time out these troughs and ridges here, and you can kind of get an idea of what is coming. And another way to look at it here, again, ridges and troughs work in tandem downstream, and they can affect the entire planet. It's just a constant battle to balance the atmosphere that the Earth can never win. And again, kind of a good diagram here by NOAA and the National Weather Service. They talk about the Madden-Julian Oscillation and the SS ENSO there. So again, probably the biggest impacts, of course, are from the El Nino Southern Oscillation. But again, when they work in tandem or phase, or they're opposite here, then the effects can be much more dramatic, or they can be evened out based on the Madden-Julian Oscillation. So kicking off a little bit more, how do we know if the Walker circulation or the atmosphere is starting to show El Nino conditions? And one way is by looking at the Southern Oscillation Index. So this is the Walker circulation, and this would be El Nino. I showed you La Nina earlier. This is where the deep air convection is out over the Pacific Ocean here in El Nino. So you would be getting the lower pressure at Tahiti and the higher pressure there at Darwin, and that is what is known as the Southern Oscillation Index. So right now, the pressure is still been lower here. We are in positive here. It's been lower at Darwin, so it's still kind of resembling a La Nina event ongoing. So El Nino, the pressure would normally be higher here over Darwin and lower pressure there over Tahiti, where you'd get the converging air and rising and the deeper convection. So here we are looking at the latest Southern Oscillation Index values. We have been for, I believe this is the last 30 days and the 90 days, we have been in positive territory. Even though the daily contribution was negative, we have still been overall in the positive realm here, going January, February, and March. Still kind of feels like that La Nina flavor. And you can see when we were in the El Nino the previous year, we were in the negative territory there. It wasn't overall a very strong El Nino, but during the triple dip La Nina, you can see how we were in the positive territory. And then when we went back this year, our weak La Nina, we have been in that positive territory all the way on into 2025. So hopefully that makes some sense. Now, what everybody wants to talk about here is, well, what does that mean overall? Well, we can look at the Climate Prediction Center here. And a lot of times during the summer months, that the signal for La Nina, El Nino, or neutral conditions is not quite as strong across the lower 48 states. But the seasonal temperature outlook here, look at this West Coast signal for below across Pacific Northwest and above for much of the West Coast. This is for months May, June, and July of 2025. Now, if we go to June, July, and August, we're getting right in the thick of summertime here. And again, above average signal. And you know what? The Pacific Northwest can be one of the driest spots in North America. And to see a below normal signal during that time frame is kind of concerning. You start to worry about wildfires and drought and things of that nature here. So that is not a great signal to see. But if you live down across the Southwest USA, I have a lot of viewers across California, the California Weather Watch channel. That monsoon signal is fairly strong, and this can push on into the California and the Nevada deserts at times as well. And if we go on to July, August, September, again, this above average signal just dominates the West Coast. And look at that signal there for the monsoon season across the Southwest, even into California and Nevada there, up into Utah, portions of Colorado, and New Mexico. So if you want to make some plans here as you go through the summer months to go down into Arizona, Grand Canyon maybe, and try to time it with one of the more active monsoon periods here, you might get multiple chances to do just that. So if we go all the way out towards December, January, and February 2025 to 2026, look at that below normal signal there. So the chilly neutral, maybe that's why the Climate Prediction Center is showing that. And you got the above average across some of the Southwest and kind of the near normal, but the above average for the interior portions of Montana, some of Idaho here as well, and some below normal starting to show up for the Southwest USA. And we go all the way into January, February, March. It's still that below normal signal right there across Pacific Northwest. And if you remember, last year's not too bad. We were somewhat below normal here once we hit the new year for the Pacific Northwest. Now, this is SeaTac snowfall season, November through March. I'm just going to show this graph here because as we get closer to the fall and winter months and we start to get a clearer picture of whether La Nina, neutral, or El Nino conditions are going to be present, we'll start to dive into what areas get what weather based on what ENSO pattern is ongoing. So we got 0.3 during the El Nino year. We got about 2.5 or 2.8. I can't remember exactly for Seattle, but that, again, wasn't either a chilly neutral or a La Nina year. So we did get more snow. So that makes sense. And you can kind of see during El Nino years, this was a weak El Nino in 2019. So that was kind of an anomaly right there. But if you look here, you can see some of these El Nino years. They tend to be on the low side of the snowfall. And then you look to some of these La Nina years, and they tend to be a bit higher. So if you want snow down into the lower elevations, you're generally rooting for a La Nina year, but it doesn't always, it's not always a foolproof way to try to predict weather here in the Pacific Northwest. But every single La Nina since 1950 for SeaTac Airport has had measurable snow. And if you look at every single year that has zero snowfall for SeaTac during that same time period was an El Nino year. So there is definitely a signal that based on El Nino versus La Nina. So anyway, Hope you guys learned a little bit here. Leave some comments or questions down below if you want me to explain things further, and I'll take that into consideration as we go on into the summer and the fall months. And of course, we'll start to look at things in more detail. We'll try to break things down. We'll get a better signal on what exactly is to come as well. So anyway, I'll do my normal briefings tomorrow. Hope you guys are having a good night, and I will talk to you guys later.